Oracle Mobile Platform team. As an iOS mobile app developer, you've probably been tasked with implementing analytics in your mobile app, and you need to understand what needs to be set up. In this episode, I'll show you how to implement Oracle Mobile Cloud Service Analytics for your mobile apps running on iOS. So let's go back to the scenario that we used in an earlier episode and imagine that you've built an application that technicians use in the field to track work orders. Let's look at what you need to do to enable your mobile app to capture and post analytics for this application. So you've maybe already heard about the MCS Mobile Client SDK, which makes calling the MCS APIs, such as analytics, much simpler. We won't go into detail about the steps for configuring the SDK because those steps are covered in an earlier episode. But let's go through a checklist of the key steps so you can make sure your application is ready to go. First, you need to make sure that your application is registered against the mobile backend in MCS. Look in the settings for the mobile backend and make sure the application is listed along with the application key. Next, make sure that the libraries for the MCS Mobile Client SDK have been imported. Here you see the mandatory libraries for analytics highlighted. And finally, you should make sure that the iOS app is configured to connect to the MCS mobile backend. In the OMC property list file, make sure that the first key contains your mobile backend name and version number, and that the settings for the base URL, app key, anonymous key, and mobile backend ID match the settings in your mobile backend. Okay, so you've confirmed that the MCS Mobile Client SDK has been imported and that the analytics capabilities are available and properly configured. Now, when someone uses your mobile app, the app can send information about system events to MCS, and you'll be able to review reports about users, sessions, and API calls. If you want to see data on custom events, though, you need to write some code. Let's see how to do that next. Let's take a look at the methods that are available in the Analytics API for logging information about custom events. The libomcanalytics.a library includes classes that enable mobile applications to post events. You can also use the classes from this library to track successful and failed posts. The OMC Analytics class contains methods for logging events, for posting all events to the server, and starting and ending sessions. A session is simply a logical grouping of events organized to capture a user's typical interaction with the app. For example, you could start the session when the app starts or when the user logs in, and end the session when the user logs out or quits the app. To begin collecting event data, you need to either start a new session by calling Start Session or call the log event method, which starts the session automatically if one does not already exist. All events are stored locally in a JSON file until the application calls either the flush or end session method to upload all buffered events to MCS. If the app is offline, it will post the events later when it's able. For long-running sessions, it's a good idea to call flush periodically to keep the server up to date and to reduce the post payload size. As an optional feature, you can implement the OMC Analytics Delegate protocol to receive updates when the Analytics API either encounters errors or successfully posts events to the Analytics REST service. Check the product documentation if you're interested in this capability. Going back to our example scenario, let's see how we can add code to the Fix-It-Fast Technician mobile app to log custom events for each step in the technician's workflow. One of the things you want to get insight on is the delay between when a technician receives an order and when the technician fixes the issue. Is there a problem scheduling service calls? Do technicians have what they need to resolve issues, or is something else causing bottlenecks? So let's add some code that logs an event whenever the mobile app user changes the status of a work order to work order on hold. The first step is to call the Shared Manager method on the OMC Mobile Backend Manager object and get access to the default mobile backend. The default MBE is the one that is specified as default in the OMC property list file. Then you call the Analytics method on the OMC Mobile Backend object to return the analytics service. For this example, let's assume that a session has already been started and that event data is being collected. To log the custom event, you call the log event method on the analytics service, passing in the name of the event, work order on hold. Remember, it's up to you what these events are called, but of course they should be representative of the information you're tracking. And finally, you call the flush method to post events to the MCS server. This example shows only one event, but you can log a series of events and call flush to post all those events to the server. Now, when a technician uses a mobile app to put a work order on hold, the event will be captured as a custom event and posted to MCS, where it can be charted in the Analytics section of the MCS UI. We're not quite done. Knowing that the work order was put on hold is useful, but since you want to figure out what's causing delays, you need to capture additional information about the event. This is where event properties come in. When you construct an event, you can pass in properties as key value pairs that provide additional information about the event. In our example, let's pass a properties argument to the log event method to add the property reason and set the value of the property to parts ordered. Now, when you look at the events report in MCS, you'll see not only that the work order has been put on hold, but you'll also be able to see the reason why it was put on hold. Let's look at one more example of a custom event, work order resolved, but this time we'll define more than one property and put everything in a new dictionary object. Just as we did earlier, we'll get access to the default mobile backend and then the analytics service. This time we'll create a dictionary containing properties that tell us more about the event, such as the location of the parts, the time it took for the technician to drive to the work site, and the time spent on site. And we'll specify values for each property, hard-coded here for convenience, of course. Again, let's assume that the session has already been started. Next, we'll log the custom event, passing in the dictionary of properties, and call the end session method to end the session and post the event data to MCS. Now, when we look at the events report, we can see the work orders that have been resolved, and we can analyze additional details, such as the amount of time that the technician spent on site. We can then use this information to help technicians become more efficient in the field. All right, now you know how to call the Analytics API to post custom events to MCS. Next, we encourage you to explore the Analytics API documentation and check out other episodes in this channel. And remember, the best way to learn how to work with the platform APIs is to jump right in and start coding.